All right, I want to look at a family of polar curves that are called Limacons. I'm going to start here with this graph that we looked at earlier. This is just the graph of r equals sine theta. It's a circle, radius half, shifted a half up the y-axis. What I'm going to do is to get Limacons, we're just going to take this sine curve and translate it vertically. So if I said plus 0.2, okay, this graph over here, which is like we did earlier, this is just like in Cartesian coordinates, x versus y, although it's theta versus r. This plus 0.2 on the outside just shifted it up. Let me show you again with a 0. Watch the red graph as I change this. Right, this is with no shift, and then when I change that to a 0.2, it shifts it up. Now what happens to the polar graph? Well, if you look at what happens over here, that in the direction of 0, first of all, I'm not at 0, I'm up 0.2. So I'm going to let this go around here and stop it. When I'm at 0, here we go, it's coming up. Oh, click. In the direction of 0, I'm just slightly away from the origin. Okay, that's a little bit positive. And then by the time I get to the highest point here at pi over 2, the radius is up to 1.2. This gets up to as high as 1, and then this is 0.2. When I'm at the lowest point, since this has been shifted up 1, this gets down to negative 0.1, but that's, sorry, negative 1, but now I'm shifting it up 0.2. So I'm really only down at negative 0.8. I'm looking straight down, but I'm backing up 0.8. So the distance that you go negative is not as big as the distance you go positive. And so this positive loop is bigger than the negative loop. And you get what's called a Limacon. In fact, this is called a Limacon with an inner loop. Okay. It looks just like, well, I mean, it's very similar to the sine curve, the sine graph that we had, but the positive loop is bigger than this negative loop, and so you see that as a big loop with an inner smaller loop. Okay. As I shift this more and more upward, so 0.2 to 0.4, watch the red graph, it's going to go higher. What happened was the outer loop got bigger, and the inner loop, because this negative is less, the inner loop got smaller. I've got this bigger inner loop all the way up to about 1.4. That was the outer loop. The inner loop is smaller. It only gets down to negative 0.6, and so that the inner loop is getting smaller and smaller. If I shift it up more, right, 0.6, you got even bigger on the outer loop and smaller on the inner loop, 0.8, right, and there's this tiny little inner loop in there, right? You only get, as I'm looking straight down, I get a distance of negative 0.2. R is negative 0.2 there, so it backs up just a little bit. When this actually gets up to 1, then the inner loop actually goes away. And you come right down to, at the bottom here, oops, I just missed it, but the lowest point, the radius is 0. There's no negative radii on this one. Everything is always positive. All I'm doing is taking the sine curve and shifting it further and further up, taking that inner loop and making it smaller and smaller. When you get to the point where the inner loop disappears, this is a Limacon with no inner loop, but it's also called a cardioid right at this point. It's got that. It turns out that right at that point there, it's very sharp. It's what's called a cusp. And that's a cardioid. It looks kind of like an upside down heart. Actually, if I wanted a right side up heart, how could I do that? What if I make this, instead of positive sign, what if I make this a negative sign? Yeah, there we go. So what I did is I just flipped that sine curve over, and so starting up here, I'm getting smaller first and then going up. So anyway, there's my right side up cardioid. Next time you need to make a Valentine's Day card, you've got an equation here you can use for a heart. So there's that. What happens if I shift it up even further? I'm going to flip this back the way I had it before. So flip this back over, make that a plus. There we go. Shift it up even more. Shift it a little too far. 1.5. There's still a little dimple in here, but it doesn't actually create an inner loop. This is no longer a sharp corner. It turns out that this is nice and smooth there. This is called a dimpled Limacon. Right? Dimpled Limacon. Sine curve just got pushed up further. This smallest point is, still some positive radius there. And you come down to, there's that closest point and the farthest away point, right? These are just telling me my R values for different theta values. Okay. Push it up a little further. There comes a point where, I believe it's right here, where the shift up is twice the amplitude, that the dimple actually goes away. This is a completely convex thing. It's not a circle, but it's almost a circle. It is convex. There's no dimple. This is called a convex Limacon, and as you shift even more, it still stays convex. So shift it up 3. It's kind of hard to tell that this isn't a circle. Let me zoom out a little bit here, see if I can see it a little better. Yeah, it's very close to a circle, but it's not a circle. Right? It is a convex Limacon. Just a sine curve shifted up or down. You can do the same thing with cosines, that if I change this to a cosine curve, you get the same idea as what you had with sine, but it's sideways now. Cosine starts at the high point, right? So if I get this back down to no shift, there's my my circle, right? Actually, I zoomed in here. Let me zoom back out again. Right, there's my circle of radius 1, and I'm going to shift it up, right? Shift it up 0.5. It creates an outer loop and an inner loop, right? That the positive got bigger, the negative got smaller. And you see those two loops. The big positive one and the little negative one. Okay. Shift it some more. When you shift it to the point that the vertical shift is the same as the amplitude, you've gotten rid of all the negatives. You have precisely a cardioid. In this case, it's sideways because I'm using cosine. I'm starting at the highest point when theta is 0. Looking in the direction of 0, I'm out here at 2. Right? Looking in the direction of pi over 2, I was at 1. Now I'm at pi, I'm back at 0. Right? Looking in the direction of 3 pi over 2, you're up at 1. And then you come back up to 2 right there. Okay. Shift it some more. You've got your dimpled Limacon sideways, and shift it enough that you get rid of the dimple. Right. This is shifting in the R direction, essentially. So there you go. Those are what are called Limacons.